and is my rod. Okay, this is my cylindrical rod. Yeah, cylindrical rod is there. So what I will do is here I will assign the boundary conditions. Before that one, I will give some dimensions here. For example, the diameter of this one is somewhat like 50 mm. Okay, diameter is 50 mm, and length of this one I am giving like 500. Okay, this is the length. So to that rod, what I will do, I will assign some tensile force. See here, this rod is fixed at one end. Here, this rod is fixed here. Okay, now to that rod, here it is fixed, and here I am assigning some load here. Tensile force I am assigning here, that is of 1 lakh newtons. This is my problem. Like I already said that analytical method usually we used under stress block material. I think we can say analytical method. So here what I am doing here, I am solving this problem now. Before with the help of this only these three values, we cannot able to find the solution, like how much deformation is coming and how much stress is introducing them. Guys, are you able to see my screen now?
Yes, sir.
Yeah. Now see here, the next thing required here is Young's modulus. Young's modulus, suppose for example, if it is a steel means the Young's modulus will be 2. See, these values will remain constant here. For every material, this value will remain constant. So 2.1 into 10 to the power of 5 is still Young's modulus value, Newton per mm square. Okay, Newton per square. Sorry,
I cannot see your screen, sir.
who is that? Tinku.
Right.
Okay, the for the remaining people that's visible now. Just to check once at your side. Okay, don't worry, one second I will share my screen. Now you can able to see.
No, sir. Shall I leave and come on?
Yeah. The remaining people are able to see my screen now.
Yes, sir.
Sandeep, Abed, Jessica.
Yes, sir.
Okay. So I do one thing, just disconnect and again. Now see here, this is my Young's modulus. One more thing I required here is Poisson's ratio. Poisson's ratio for steel is 0.3. Okay, it's a steel rod. Based on that one, these two values will remain constant here. Okay. Now, I am solving this problem. I will find what is the stress is generating here and how much deformation the object is facing. So first of all, what I will do, we have the formula here. Stress is equals to load by area or force by area. Okay. Now here we have force is equals to 1 lakh newtons. Okay, force is equals to 1 log newtons and area. Area is equals to, we have the formula like pi r square. Okay, pi r square is the formula for area of the circular thing. Like it's a circular rod, so that's the reason we have to find the pi r square value here. So which is equals to 22 by 7 into, what is the r? R is radius here. So here we have diameter. So diameter by 2 is radius. 50 by 2 is 25. So the radius of that circular thing is 25. So 25 square. 25 square. Okay. Now if you calculate this value, so what is the result here? Just do it fast. We will do here 22 by 7 into 25 into 5. So it's around 1964.28. 1964.28. Okay, that is my area of the cylindrical rod, cylindrical circular thing. Now I have to find the stress. What is stress here? Stress is equals to force by area, which is equals to 1 lakh divided by 1964.28, which is around 1964.8. It's 50.96. Okay, 50.96 is the stress is induced in that rod after assigning that much load. Okay, now the next thing what I am doing, I am finding the deformation. Deformation in the sense like with the help of strain we can able to find the how much deformation is generating there. So strain is equals to changing length by original length, but we don't know the strain value also. We don't know strain value also. We don't know change in length. Means we have to find change in length only. So strain value also we don't know. Only we know that length of the rod. So with the help of strain also directly we cannot able to find. But we can do one thing. We can go with the help of Young's modulus. So Young's modulus is equals to stress by strain. Okay. Under elastic limit, stress is directly proportional to strain. That is your Young's modulus. Then stress is force by area whole divided by strain is change in length by origin. Now I have to find the change in length here. So your formula will become change in length equals to force into area, force into length divided by Young's modulus into area. So change in length you can find from this formula. So now change in length equals to, what is the value there? 1 lakh into 500 divided by 1962.28 into 2.1 into 10 to the power of 10 to the power of 5. Okay, so this one values, these values we have to calculate here so that we can able to find the change in time. So what is that thing? 1 lakh into 500. It is around 5 lakhs. Okay, it is around 5 lakhs. Sorry, 50 lakhs. See here, 10 to the power of 5 and 1 lakh both are similar. This is also 1 lakh, this is also 1 lakh. So both get cancelled here. Directly what I will do, I will go for the option here. 500 divided by 1962.28 divided by 2.1. It is around the 0.12. Okay, it is around 0.2 mm is the deformation you are getting here. Understand, guys? So now the same thing we will solve under the Ansys software. See here, I am not telling you the procedure how to solve in Ansys. Just I am showing you the how the results are coming. Okay. Now, okay, just share your screen. Okay, share your screen. Yeah, thank you, Akshay. Now see here, these are the, see this is our environment here, screen, like Ansys software workspace we can say here. On the left side, this one we can say as a toolbox, okay, which we are seeing here. Now this one we can say as a toolbox. Under that one we can find different kinds of analysis. Okay, whatever you want, you have to choose here and we have to perform here. So right now, see here the problem which we have done, that is our structural analysis. You can see. So many types of analysis are there. I will tell you what are those things. So first of all, I will tell you the, like this time I'm solving the basic problem here. So first thing is structural analysis. So where is structural analysis? It's somewhere here. So this structural analysis I have to perform here. Just do one thing. Just double click on the static structural, or just pick and drop here. Okay, pick and place like this. So just double click on that one. So automatically your project has been generated here. So under that only you have to perform different operations. Now see here you can find different things are there. So based on that one only we have to solve our problem. First thing is the name of this one. See here bottom also here it is the type of analysis showing in the first one. And the bottom side also showing some static structural, that is the name, what kind of name you require. I am giving the name as linear analysis. Okay, linear analysis. So name has been generated here. Now what I will do, the second step is here engineering data. So what is engineering data here? So see here, whatever property, like whatever material you want to assign to your object, every material is present in your engineering data. From that engineering data only you have to assign the material to your object. So for that reason, to assign the material to your object, first of all what you have to do, you have to double click on the engineering data, or we can do right click and click on edit option. Just double click on the engineering data, automatically this environment will open here. So there you can choose what type of material you require. Okay, I am performing the structural steel structural analysis here. So see here, So you can change the materials. Right now, I already said that this is steel. So in steel also different types of alloys are there. So right now it's taking some structural steel whose Young's modulus is mentioned as 2.5 10 to the power of 8. But it is in Pascal. But I want this value to be in megapascal. So just click here, go for MPa. Now see here it is 250 megapascal. If you go for gigapascal GPa, then you can find it's 0.25 MPa. So this value I have to specify it like 2.5 into 10 to the power of 5. Oh, wait a second. It's better actually. The thing is not with me. Yeah, I will keep this value like that only. Why? Because MPM is that one only 2.5 20 to the power of 5. So now see here I got this value. See, whatever of property you are selecting here, below you can find the details of the property, like what are the values and the, like what is the tensile strength, what is the compressive strength, ultimate strength, compressive ultimate strength. So many properties you can find here. So which one you want to change, you can able to change here. Like even density also you can able to change here. So whatever values you want, you can change here. Oh, it's not scrolling down. Here we have to, okay, here you can find the isotropic elasticity. Yeah, here it is actually. This 250, whatever we have seen here now, that is your ultimate. Means we can, you already know the stress strain curve now. Under that one you can find the option ultimate stress. Means after that one the deformation will get started. Okay, that is the ultimate strength. Now see the value is 2.5, sorry 2.1 into 10 to the power of 5. Then the next thing is Poisson's ratio is 0.3 only. That's great. We also require that much only. Then the next thing is, yeah, that much only. Like any two values we have to specify Young's modulus and Poisson's ratio, or whatever you want. See, for example, if I want to specify Young's modulus and Poisson ratio, choose this option. If you want to specify shear modulus and Poisson ratio, choose this one. If you want modulus, bulk modulus and Poisson ratio, you know, and the remaining values you have to find, means you have to choose this option. See here we have four properties are there. Young's modulus, Poisson's ratio, bulk modulus, shear modulus. Any two values we have to specify, the remaining two it will automatically calculate with the help of some standard formulas. Okay. Now see here, right now I know only Young's modulus and Poisson's ratio, so those two values I am specifying here. So the remaining two values it is automatically calculated. Okay. Now see here, our property has been assigned here. So what I will do, I will close this one. Now my property has been assigned. Now what I will do, I will go for the next option, that is geometry. Now the next thing is geometry. Don't double click on geometry because it's the latest version. Here directly it will open the space plane. So that is not good for you. So right click here. You required here design model. Don't go for space plane. Both are similar only actually, but in space plane you get some confused. See, two options are the new space plane geometry, new design modeler geometry. So any one you can choose, but don't go for space plane because there are some difficult options are there which you have to which is difficult for you to understand. So go for, it's better to go for design modeler. So new design modeler, click on that one. So it will open one more environment here where we can able to do modeling work. Okay, just click on that option. Thank you. It should be a very high configuration, otherwise the software will not work properly. Hmm. Wait. It's loading. It's showing at the bottom and you can find the status bar. Here it is showing that starting design model. On the top left corner, sorry, bottom left corner you can find it. Starting design model means it's loading, yes. So don't again and again open it. Otherwise it will completely get stuck. Yeah. So your design modeler environment has been opened here. Now what we have to do, we have to create the body. See here directly we can import also. So if we create in any other software, we can able to create here also. Sorry, we can able to import also. But right now it's a small model only, like just a simple cylindrical rod. So that's the reason what I am doing directly. I am creating here only instead of creating any other software. So what I will do, I will create one body here. So in that case, it's better to go for the. See here you can find some options for creating like extrude, revolve, sweep, thin or thick surface, blend, chamfer, slice, point. These are the objects creating like modeling commands you can find here. With the help of this one, you can able to create the bodies. Uh, Here also you can find some options. Here, like if you click on this create option, here also you can find the options for creating the things. Next concept is there. Here also you can find some options for creating the things. Here also you can find the options for creating something. So whatever you want, you can take from here and you can able to do the work. Right now I am going for the create option. Here primitives I will take and I want the cylindrical body. Go to create primitive. Primitives means it's a predefined shapes. Okay, you can say as a primitive. Go for cylinder. So directly it is going to create here. So why should I create sketch there? All those things. Now, uh, zoom in here. Now I require the values here to specify here. See here. Right now, the object the values which it is showing here are in meters. Okay, so what I will do, I will change the unit system here. So go for units. Right now it's not taking. Why? Because we are under in command now. So it's a reason it's not taking here. I will delete this thing first. Yes. First go for units, change the units to millimeters. Now go for create, primitives, cylinder. Now you can able to specify the value. Like I want to give, see here radius of the cylinder, it is 25 is the radius, and the length of that one it's mentioned as 13. Now so I want this thing to be like 500 mm. Now see here it is generated here now. After giving the values, don't click escape or directly go for the next command. Why? Because still just showing that value is not generated. So after giving all the values, here you can find the option here generate. If you click on generate, then only it is going to create here. So click on generate. Now see here, your rod has been created now perfectly. Okay. Then what you have to do? Go for file, close design model. Now see here our model is also ready now. It has been created. Now we have to go for the model. So in model, what are these things I will tell you later. Just I am showing you the problem first. Now go for model. Just double click on model, it will enter into the another environment where we can able to assign the boundary conditions to the object. Still it's loading. Now see here, you are modeling environment. Okay, mechanical. So it has been opened here. Wait a second. Actually, just right click on model. Go for edit. Okay. They change the environment. Okay, fine. Now see here, it is like that now. The first thing what here you can find so many options at the left side. It's like a specification tree which you have seen in your modeling environment in other only. So here we have to assign the boundary conditions on all those things. Okay. Now see here, the first thing is geometry import. Okay. If whether you have imported any geometry, it will show you here. So what is the geometry? It's solid or surface, whatever it may be, you can find here in geometry option. Okay. Here you can find the geometry option. Here you can able to see the things. Now it is showing it's a solid body. Then what material we assigned? It will show you under the we assigned the structural steel. See here this right mark we are seeing here now, beside that one. With the help of this one only, we have to identify that whether it is properly assigned or not. Okay, whether it is properly assigned. If it is showing something like this one, some S kind of thing you can able to see here. With that, if you see that one means we need to update that. Okay, like that. Now the next thing is everything is showing us right. Means everything is till now it's going perfectly. Now the next thing is it is showing update option here for mesh. Means we have to generate the mesh here. What is mesh means converting your infinite particle object to the finite element object. So for that one we have to generate the mesh here. So right click on that one. Here you can find the option generate mesh. So it will generate the mesh here. So the machine is generating here. See here, whatever solutions you will get, so it's totally depend on the mesh only. See here, the mesh has been generated here. Then the next thing what we have to do means we have to assign the boundary conditions. Okay, so where we have to assign the boundary conditions? See here, one end of the rod is fixed. Okay, one end of the rod is fixed. The other end we have to assign the load. Okay, so for that one, what I will do, I will go for the option. See here, you can find the option static structure, which we are performing the analysis right currently. So what you have to do means right click on that static structure. Right click on static structural. got stuck here. Okay, you just try with him, right click there on static structure. Okay,
Sir. So next.
so just to go, just keep your cursor on static structural and right click on that. It got stuck. Okay, guys, we'll check tomorrow. It's better. I only have to install the software in my laptop, but my laptop doesn't have that much configurations. Okay, let's see. I will try once. If it is working, means we'll continue. Otherwise, we'll see what is going to happen. Okay, then fine, guys. Tomorrow we'll meet the same time, and we will check tomorrow. Okay.
Good night. Bye, guys.
Sorry.